So let's look more about these particles. These are often called subatomic particles because they're particles that are smaller than an atom. They're below an atom in size. So we need to understand and know some things about these particles. So these are their names: proton, neutron, and electron. These are the three main subatomic particles. There are other particles, but we're not going to talk about them at this level. So here are the masses. You don't need to memorize these. A proton is 1.67262 times 10 to the minus 27 kilograms. That is crazy small. That's so small that a unit like kilogram just doesn't work. Even a picogram, which would be 10 to the minus 12 grams, still isn't going to work. And so scientists actually created a unit, which may sound strange. Oh, they made up a unit. All units are made up. They made up a unit to use, and they called it the atomic mass unit. It's useful for determining atomic mass because the size of it is on the scale with atoms. When we measure a piece of paper, we don't want to use kilometers because the unit is too big. So when we're measuring the mass of these particles, we want to use a unit that's small. So the atomic mass unit, abbreviation AMU, not MU, is 1/12 the mass of a carbon-12 atom with 6 protons and 6 neutrons. Sounds like a kind of a crazy way to define a unit, but there's some genius behind it actually. So in atomic mass units, a proton is 1.0073, a neutron is 1.0087. Those are awfully close, aren't they? For our purposes, we can consider them to be the same. We'll just call them one atomic mass unit. The electron is a lot smaller, 0.00055 atomic mass units. Then the charges, positive, 0, and minus 1. So, let's see here, I need a color. Proton is positive. They both start with P. Neutron is neutral. There's a positive, a neutral, and a negative. That means the electron has to be the negative one. Plus 1, 0, minus 1. You need to know the charges on them. Relative masses, we're just going to call this one 1 and 1, and this is essentially 0. It is so small that it just really doesn't matter. It's like if you have a big moving truck and you've loaded stuff up and you take it to the truck scale and you weigh it, and then you go home, oh, there's a couple other things, I forgot to throw these 2 pillows into the truck. Do the pillows have mass? Yeah, pillows have mass. Does their mass matter in comparison to the mass of the truck? Do you need to go back to the truck scale and weigh it again after putting in 2 pillows? No. It's so small, it just doesn't matter. And that's how we often view the mass of the electrons. Electrons do have mass. My husband had a great t-shirt once. A student gave it to him. Said, electrons have mass? I didn't even know they were Catholic. Electrons do have mass, but they're so small that for a lot of purposes we just don't even count them. So, subatomic particles. This will give you an idea of how small the electrons are. If the proton had the mass of a baseball, an electron would have the mass of a grain of rice. Baseball's not super heavy, but compared to a grain of rice, it's pretty big, right? The proton is almost 2,000 times bigger than an electron. So we can just kind of ignore the mass of an electron. So Rutherford's particles, most of them went straight through because the atom is mostly empty space. Visualize the P on the 50-yard line. There's some electrons. Maybe there's 10 or 12 electrons, and they're each 2,000 times smaller than the green P. They're not going to matter much at all. They're like specks of dust. There's tons of empty space. Yeah, those particles went straight through. So why does matter seem solid? This desktop seems pretty solid to me. Well, let's look at this picture of this jungle gym. If you look at a big jungle gym like this and you back up, this looks pretty solid, doesn't it? You see some little open spaces here. But when you get in closer, you see that there are actually big open spaces. Maybe we could think of like a volleyball net. You string up a volleyball net. Could you take an airsoft gun and shoot pellets through the volleyball net? Yeah. In fact, it would be hard to intentionally get them to bounce off the strings of the net, right? It'd be hard to hit them. Big empty spaces. What if you took 500 volleyball nets and strung them up right next to each other? They're not all going to overlap, are they? So that all the holes line up. They're going to overlap with each other just like this jungle gym does. And so they're going to look like they're solid. So that's kind of interesting to think about. The particles that bounced back, what happened with this jungle gym? Well, they hit the metal bar. Is it possible to do that? Yeah, it's possible. But, if you stood at this jungle gym and we're shooting airsoft pellets through there, because, shooting BBs on a playground would be a bad idea. Even airsoft pellets, that's kind of iffy. But shooting pellets through that, you could shoot them through, but some of them would bounce back. So that's just kind of an illustration of matter. So here's another little bit of physics. Electrical charge. So we have to have a basic understanding of electrical charge. Opposites attract and like charges repel. So if you have two oppositely charged objects, positive and negative, they will be attracted to each other. We don't deal much with electrical charges. Children are not given electrical charges to play with, but we do give children magnets to play with, don't we? And you've probably all played with magnets. They're pretty fascinating. You get two magnets and you align them the right way and they just stick together, don't they? The cover on my iPad is magnetic. It just sticks. It's like magic, It's magnetic. But like charges, if you put two north poles of magnets together, they will repel each other. My kids have Brio trains. I think it's about time to put those away for the grandkids, but they still get them out occasionally. So you get the two Brio trains, and if you line them up right, the cars stick together, and you can make it go around. If you turn that car around and you try to hook them up together, they bounce off of each other. So like charges repel, and opposite charges attract. We also can talk about adding charges, just like we add positive and negative numbers. So if you add a plus charge and a minus charge together, overall you're going to end up with something that's neutral. And that's what happens in the atom. We have negative electrons and positive protons. And when we have an equal number of them overall, the whole atom is neutral.